Okay, Too Tall Toby Challenge 240308. We are in alloy, we are in grams, we are going to make a lot of revolves. I have students who really try to avoid this, so I love revolves. There's a couple of things to remember as we jump into a part with a lot of revolves. You got to make sure you have an axis of revolution. I always do my sketches inside the revolve because then I get diameters to show up instead of radii. And make sure that your line, when you close the loop, and do close the loop, is a continuous line in the center. All right, let's jump in. We are going to do a revolve on the front plane, and I always start my revolves with a axis of revolution. There are two center lines. There is a datum center line and a construction center line. Make sure you're getting the axis of revolution, which is the datum center line. All right, we're gonna do some sketching out here. I'm gonna do this as two separate revolves. So we have an overall height of 175. This thickness here is 12. And because this sketch is done inside the revolve, that gives us this diameter of 51. Let's see here. Do I have this diameter? I do. 28. And then I need this angle. So let's give that an angle of 120 divided by 2. And I think that's everything. All right, let's revolve it. Beautiful. So it automatically takes the internal center line, goes 360 degrees. We love it. We're going to create a sketch to make the two little cuts. We'll use the previous sketch, and we'll just drop a couple of circles on here. All right, so I'm going to give that a diameter of 8. And to locate these, I'm going to use these little helper points, just because if I had actually made the cut, it might show up easier, but with the circles there, it's just not exactly always giving me the dimension I want. So the little construction geometry points will help. I did not select an axis of revolution that time, shame on me, but I can select it because I have one from previously. I don't want to add material, I want to remove material. Great. And then last thing we're going to do is make the little cutout for those, the cross shape. So this one I'm going to try doing, a sketch region with a center rectangle. We're going to do 2 of those. I like those being equal. Do that. Set this width to 5, and then we'll also make it tangent on the outside. All right. So let's, I don't know that this is going to work. We're going to do sketch region. Interesting. I'm up for this challenge. All right. We're going to extrude this out. Yes, it works. Perfect. We're going to have a depth of 120. Control D. That looks right. All right, so if we drag that down and do a Control G, Control R, 200 grams. Let's see how we did. All right. So what are we missing here? 5 and 5, 12, 175, 120, 20 degrees. Oh, wait, radius of 4, but that's a diameter of 8. That's okay. 28, 8, 8, 7, 6. 51. Let's see here. We are in alloy. It's alloy. Let's go to feature and see what we got going on. We got 12. Ah, that helps. All right, this depth is 120 minus 12. That is our issue here. So let's edit definition and make it 120 minus 12. And that does look more like the part. All right. Second time's the charm. There we go. Okay, so this one I did a revolve and a revolve remove material. I selected an axis for an internal center line instead of sketching one. I used the previously sketch on previous option to reuse that original sketch plane. And for the plus sign there, I used the sketch region option. So also got tricked by where that depth was coming from. So easy to do. And there we go. All right. See ya.